Today's lesson is solving multi-step linear equations. My learning objective is I can explain the steps for solving linear equations by using academic vocabulary. Let's take a minute, and if I've never heard this before, I'd call myself a novice. Or if I know what everything is before I explain it, I call myself an expert, or I'm somewhere in between called an apprentice or a practitioner. All right, let's start by saying the first example I want to talk about is when I want to distribute. When I distribute, I am multiplying the terms outside the parentheses to the terms on the insides of the parentheses. So a lot of times we'll see these arrows. So 5 times 3m is 15m, and 5 times 4 is 20. Okay, next thing I want to hear for academic word is combine like terms. Okay, so combine like terms means the same power of the variable on the same side of the equation. Okay, so let's look on the left side of the equation. So the like terms I have are 2y and minus 7y. And I have a constant, minus 5 and plus 4. Okay, so on the left side, I can write 3x minus 5y minus 1. Okay, on the right, I'm going to do the same thing. I'm going to combine my like terms. So I have a 8x and a minus 4x. So I have 4x plus 3. So combining like terms only has to do with one side of the equation. Okay, next. To move terms to the other side of the equation, I add the inverse. Okay, so adding the inverse means I am using the opposite sign so that my total equals 0. So this is the big picture. When I have plus and minus the same number, my total is 0. So to add the inverse, so if I want to add the inverse, if I have plus 3x, the inverse would be minus 3x. Whatever I do on one side of the equation, I have to do on the other side of the equation to keep it equal. So this totals 0. So I have 5y equals 18 minus 3x. My second example, if I have a minus 6, the inverse is plus 6x. So I want same number, opposite sign. So this totals 0. So I have 2y equals negative 11 plus 6x. Okay, so next I want to divide by the coefficient next to the variable. Okay, so some of the big pictures I'm talking about is any number divided by itself is 1. So right now I have 2y equals 5x plus 6. So my last step would be dividing by 2. That is the coefficient next to the variable. So I do this to every term. So 2 divided by 2 is 1. So I get y equals 5 halves x plus 3. And my final step is substitute. This is where I'm going to plug into the equation to solve if I need to. So if t equals 2, and I want to substitute 2 in for t, this would be 5 times 2 is 10, minus 8 is 2. All right, let's do a couple examples inside. All right, so we're talking about linear equations right now. So a linear equation is a polynomial of the first degree. So my exponent equals 1. I have no more than 2 variables. The graph is a straight line on the Cartesian coordinate system, and I read the graph from left to right. Okay, so I read the graph from left to right. I need to recognize that a positive slope increases as I move to the right. A negative slope decreases as I move to the right. A zero slope is horizontal. And an undefined slope is a vertical slope. All right, let's do a couple examples here. Let's solve for the variable. Here's an example with adding the inverse. So I have 5p plus 6 equals negative 4p minus 8. So I usually move the smaller to the larger. So negative 4p is the smaller. So my inverse, since I'm negative 4p, is going to be positive 4p. Whatever I do to one side of the equation, I have to do to my other side to keep it equal. So I get 9p plus 6 equals negative 8. Next, I'm going to move my plus 6. So my inverse is minus 6. I have 9p equals negative 14. My last step, I'm going to divide by the coefficient next to the variable. So I'm going to divide by 9. So 9 divided by 9 is 1. So I get p equals negative 14 over 9. Okay, next example, distributing a negative number. Okay, so I have really a negative 1 here, so I want to distribute negative 1 on both terms inside the parentheses. So I just change the sign. So this becomes minus 5z minus 12 equals 18. I'm solving for the variable, so next step, I want to add the inverse. So I want to move negative 12 to the other side. So I do that by adding the inverse. So I have negative here, so I'm going to add 12. Whatever I do to one side, I have to do to the other side to keep it equal. So minus 5z equals 30. Last step, I'm going to divide by the coefficient next to the variable. So I'm going to divide by negative 5. Negative 5 divided by negative 5 is 1, so z equals negative 6. All right, let's try some with some fractions. Okay, so when I have some fractions, to start solving my equation, I want to clear the fraction. So I'm going to look at what I have in the denominator. So I have a 5 in the denominator. So I want to clear my fraction by multiplying all the terms by 5. So I'm going to distribute this 5 on every term. So 5, so I'm going to multiply this, is going to be 5 times 5r minus 5 times 1 divided by 5 equals 5 times 4 divided by 5. Okay, so and the 5 divided by 5 becomes 1, and the 5 divided by 5 becomes 1. So 5 times 5r is 25r minus 1 equals 4. Okay, so I'm solving for my variable. I want to add the inverse, so I'm going to add 1. So 25r equals 5. I'm going to divide by the coefficient next to the variable. So I'm going to divide by 25. 25 divided by 25 is 1, so I get r equals 1 over 5. Okay, let's try another one. I have a 4 outside the parentheses. So I'm going to distribute the 4 and the 2 terms inside the parentheses. So 4 times negative 2d is negative 8d. And 4 times negative 3 is negative 12 equals 12. I'm going to add the inverse. So I'm going to add 12 to both sides. It's total 0. So negative 8d equals 24. I'm going to divide by the coefficient next to the variable. So I'm dividing by negative 8. Negative 8 divided by negative 8 is 1. So d equals negative 3. Okay, let's try one more with a fraction. Those are everybody's favorites. So I see that I have a 3 in the denominator. So I know I want to multiply all my terms times 3 to clear the fraction. So 3 times 2/3 m minus 3 times 6 equals 3 times negative 10. So 3 divided by 3 is 1. So I'm left with is 2m minus 18 equals negative 30. I'm going to add the inverse. So plus 18 is total 0. So 2m equals negative 12. I'm going to divide by the coefficient next to the variable. So I'm going to divide both sides by 2. 2 divided by 2 is 1. So I get m equals negative 6. Okay, let's do a couple SAT problems that are related to linear equations. These are examples of no calculator questions. You have a minute and a quarter per question, and these are classified as heart of algebra. So this is a time test, so we don't have time to work these all backwards. You need to apply the concept. If you can't get the answer, you want to eliminate the ones you know are wrong and then guess because you really don't have much time. Okay, so this is an example of a linear equation interpreting the y-intercept. So a linear equation is y equals mx plus b. The y-intercept is b. Okay, Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated at p equals 108 minus 23d, where p is the number of phones left and d is the number of days she has worked that week. What is the meaning of the value of 108 in the equation? So the 108 is the constant. That's why I know it's the y-intercept. So Kathy will complete the repairs in 108 days. Kathy will starts each week with 108 phones to fix. Kathy repairs phones at a rate of 108 per hour. Kathy repairs phones at a rate of 108 per day. Okay, so the rate is 23. So I know these with rate are the slope questions. And 108 is what she's starting with. And then she's subtracting. So this is the y-intercept is she has 108 phones to fix at the beginning of the week. All right, here's another equation. This is a linear equation interpreting slope. So rate is the key word, or each. A pediatrician uses the model above to estimate the height of a boy in inches in terms of a boy's age A in years between the ages of 2 and 5. Based on the model, what is the estimated increase in the boy's height each year? So the word each here has to do with rate, which means slope. Okay, so slope is what's with the variable. So it's asking me this right here. So I know we are talking about 3 inches. Okay, we're done.